All right, so we're working on the midterm study guide, and I'm working some of the problems through here. I'm on number 18 now. On number 18, we're solving this equation. So the policy is anytime you see a fraction, you want to clear a fraction. So there's fractions in your problem. You want to try to come up with a way to times through by the LCD, clear the fractions. Well, in this one, we've got, this is a prime factor in the denominator, a prime factor in this denominator, so we're going to need one of each of those. But this actually factors into these two. So the key on this one is to start with factoring. So this actually factors into these two amounts, which takes care of our LCD. Our LCD will be one of each type of factor. So we've got this, which is already there, and this, which is already there. So that is our LCD. And when we times it to both sides of our equation, it will cancel out all of these fractions. So we take the left side times this LCD, and the right side of the equation times the LCD. And when we multiply, multiplication we know distributes, so it times multiplies into each of these terms, and then of course it'll multiply onto that term. So basically it multiplies onto each term. So we apply this LCD times each part, knowing that multiplication cancels diagonally any matching factors. This is like over 1, you know. So when you multiply, the diagonal parts cancel out, and then you multiply what's left, the 4, the x plus 6. Then we distribute. I have to go back. I'm canceling it out when I multiply here, but I use it on each term. So I go back to my original LCD. I times it by the second factor. The x plus 6 is canceled. So multiplying what's left, looks like that. Notice there's no denominator. They're wiped out, no denominator. On the other side, this is an exact match, so the whole thing just cancels out, and you're just left with the top number 7. And then we have a much easier equation to deal with. We can distribute and solve that. Much easier now without the fractions. So combining your like term, we've got 11 x's. 24 and minus 81 is, what is that, 57. Then solve by taking the 57 across the line, making a total of 64. Oh, I've got 11x equals 64. And then divide by the 11. Uh-oh, did I subtract wrong? And I should get, number 18. It says answer B. So I should have a 13 here. I'm thinking, oh, this should, 4 and 9 is 13. That's my problem. Let's fix that real quick. So 4x plus 9x is 13x. So I should get a 13 on the bottom. Sorry about that. I'm too lazy to reshoot the video, so we're going with it. So 64/13 is answer B. All right, number 19. Number 19 and actually 20 go along with the same formula. So if you want to just make note of that, they're both work problems. So you've got two things working together. On example 19, it's a water tank. A water tank that's filling up in 6 minutes, and it can be emptied in 8 minutes. So eventually, it's filling up faster than it does leak out, so it would still fill up if the drain is accidentally left open, like it says here. It says when the tank is being filled, so how long does it take to fill the tank? So like I said, you can still fill it up even though it's got an inlet that takes 6 minutes and an outlet that'll drain it in 8 minutes. It can be filled up. But the premise of work problems is you multiply rate times time, just like we do in distance problems. Rate times time tells you how much work you get done or how far you get in distance. So we use kind of the same idea. Again, work equals rate times time, and so does distance. We did distance problems as well for reading problems, but here we're doing work. Work is rate times time. So the rate of anything would be 1 over how long it takes it to work on its own, like to complete a job. So 1 over its individual time. So if something takes 6 minutes to complete, then its rate is 1/6 of a job per whatever unit of time we're talking about here. I think we're in minutes. So 1 over the individual time times the time together, how long if they work together, plus 1 over the other individual times together. And if there would be a third person, you'd put it over there. But we try to equal 1 job completed. Now, in this case, they're working against each other, so I'm going to change it to a subtract. This is the format if they're working together. You add each person that's working together, and you add them to equal 1. But in our case, they're working against each other, so we'll put a minus. So our formula on number 19 would be 1 over 6, that's the one drain working alone, times the time together is what we're asked to find here, x. We're going to put a minus because they're working against each other. The other drain I said is 8 minutes times the together time. So you just put the individual times down here in the format, and then you set it equal to 1. And fractions again, so I times by the LCD for 6 and 8. The LCD is 24. So I times each side by 24. 24 distributed into this will be 4x minus 3x equals 1 times 24 is 24. And that solves out to be 24. So in 24 minutes, it's going to slow the process down a lot because of this outlet drain that's leaking out, but it still can fill up this tank in 24 minutes. All right, and that's answer D. So we're going to do that again in number 20, only it's going to be a plus, but it's the same little format, 1 over individual times together, plus if they're working together, minus if they're working against each other. All right, so let's fill in number 20. Again, I said it's a very similar problem. Martha and her brother are raking leaves in number 20. It says Martha can rake the leaves in her yard in 2 hours. Her brother takes 4 hours. So we know the individual times. We know Martha is 2 hours. Times together is what we don't know in this one as well. Plus brother is 4 hours, that's the individual time, times the together time we don't know, and we're trying to equal 1 job completed. The yard is raked, completed. Not a fourth of the job, not a half of the job, but the whole job completed. So that's why we set it equal to 1 job completed. All right, so we've got our setup again. Our LCD is 4. We times each side by 4. 4 distributes on this side being a 2x. 4 times a fourth is a 1x, and 4 times this side 4. That adds up to be 3x equals 4. Divide by 3, 4/3. So about an hour, 1.3 hours would be if you did it as a decimal. But let's see, the answer key left it as 4/3. 4/3 of an hour, so a little over an hour. If they work together, they get the yard raked on number 20. All right, let's do one more on this little section. 21 is a radical problem. And what we know when we work radical problems is even after we solve it algebraically, sometimes the answers don't work back in the original problem, so you have to check these. I would recommend you do that on all your problems, but especially on some of these problems in like the 1.6 area, you really have to check these. So with a radical, the first step is to isolate it, get the radical alone on one side, any other terms throw across the line, so I'm going to bring down the x, and then this comes over to be a -5. So isolate the radical, then since it's a square root, if I square it, the square and square root will cancel each other out, bringing out the x plus 7. What you do to one side must be done to the other side. So on this side, when I square that, x minus 5 squared means x minus 5 times x minus 5 times itself, you know. So that would be FOILed out, and you can see how that works. And it looks like I've got a quadratic equation. Because of the x squared, it is a quadratic, so that means get everything to one side equal to 0. So I'm going to bring all the terms over, so minus x minus 7, get it equal to 0 in standard form for this quadratic. All right, so here's our quadratic in its standard form. From that form, we know you can use the quadratic formula if you prefer. A is 1, B is -11, and C is 18. I'm going to demonstrate it by factoring. What works is x minus 9 and x minus 2 multiplies to be positive 18 on the end, but give you the right -11 in the middle. then set each factor equal to 0. It gives me two potential solutions. And like I said, in this particular type of problem and some of the others in this little section, you must check your solutions. They look good, they work algebraically, but back when the original problem before we squared it, it could be a different story. So you have to plug it back in, which is a good idea really whenever you're working a math problem, is to see if your answer truly works. Oh, wait a minute, I went back wrong. So in the original problem, you know, it looked like that. So when I plug in 9, I'll have square root of 9 plus 7 plus 5, plugging in 9 for all the x's. See if that's true. That would be the square root of 16, which is 4. 4 plus 5 is 9. That checks out. So we can say, yes, that answer's good. Then we have to check the 2 as well. So square root of the original equation, you know, we've got to plug in 2's for the x's. Square root of 2 plus 7, I keep wanting to call that a 9, but equals 2. So that is square root of 9 plus 5 equals 2. So you see, that's not true. It just does not work. So sometimes that happens in these and you just can't foreknow it until you just check your answers. So the only answer you would accept is just the 9 should be answered. We'll stop it there.